Hi, welcome to Mrs. Park's geometry class. This is chapter 2, section 6, algebraic proof. So in last section we learned a little bit about paragraph proofs, and today we'll learn more about algebraic proof and two-column proofs. Okay, so why are we learning this? Some cars have displays, let's go back. Some cars have displays that show the outside air temperature in Fahrenheit or Celsius. The Celsius scale sets the freezing and boiling points of water at 32 degrees and 212 degrees, respectively, while the Celsius scale sets them at 0 and 100. You can use an algebraic proof to show that if these scales are related by the formula, C equals 5 over 9 multiplied by F minus 32, then they are also related by the formula F equals 9 over 5C plus 32. So an algebraic proof is algebra is a system with sets of numbers, operations, and properties that allow you to perform algebraic operations. The following table summarizes several properties of real numbers that you studied in algebra. So here you see a table with all the properties that you've learned in algebra, and you should be familiar with this. Addition property of equality, A equals B, then A plus C, same as B plus C. So all you really did here was add C to each side, and they're still equal because they said A is equal to B. Same for subtraction, same for multiplication, same for division. So if they're equal, they tell you they're equal, you can add, subtract, multiply, divide the same number or same variable on each side, and you should still be equal. Reflective property is A equals A. It's kind of like looking in the mirror, like a reflection of yourself. It's the same, A equals A. Symmetric property is if A is B, then B is A. If A is B, then B is A. Transitive, if A is B and B is C, then A is C. Okay, this is kind of like the law of syllogism, right? We learned that. So it's kind of similar to law of syllogism. Substitution property, if A is B, then A may be replaced by B in any equation or expression. So substitution, you learned a lot in algebra when you substitute a letter or a number for a letter. Okay. Distributive property, we're familiar with this, A times B plus A times C. Okay, so these are all skills that you've already learned in algebra. It's just nicely made here in a table for you. Alright, so an algebraic proof is a proof that is made up of a series of algebraic statements. The property of equality provide justification for many statements in algebraic proofs. So really what we're doing is we're going to prove, when we solve this, x is going to equal 18. Okay? But by justifying each step with a property, okay, we're showing that it's not just because, it's because of these properties, all these rules that we're following, that x equals negative 18. So we're going to solve. So what would you normally do when you want to solve for x? You multiply the negative 5 by using the distributive property. Okay? So that's what they did. Negative 5 times x, negative 5 times 4, and they wrote there, it's the distributive property. Okay, next, what would you do? Okay, you would simplify the negative 5 times x into negative 5x, negative 5 times 4 into negative 20. So when you're substituting, when you're actually solving something and making it look simpler, that's when you use substitution property. Okay? So instead of writing negative 5 times x, I wrote negative 5x. Okay? Instead of writing negative 5 times 4, we wrote negative 20. Okay, so you're just substituting. Then you would add 20 to each side, and that's called the addition property of equality. Then you would divide each side by negative 5, and that's the division property of equality. And you have your answer. So when you finally get to your answer, that's when you use the substitution property of equality. Because you got to your answer, so instead of writing 90 divided by negative 5, you're writing negative 18. So here is your turn. Did we skip anything? No, okay. So here's your turn, numbers 1A, 1B, 1C. So So you are writing the property that you're writing for each step. So it's good that you got practice on how to write out each step. It's as if you're writing a textbook, okay? You're gonna write out each little baby steps, okay? I know you can do faster than this, but you have to write out each separate step and tell me what property you're using, okay? So just like that, make sure when you write down this problem, 1A, and then go back to all the properties, and then you can use that as a reference. Okay, so pause this video and look at this table to solve your problems, and come back when you're done. Okay, welcome back. Right, so example one, example one we did together, is a proof of the conditional statement if there's a problem, then, okay. Notice that the column on the left is a step-by-step process that leads to a solution. The column on the right contains the reason for each statement. In geometry, a similar format is used to prove conjectures and theorems. A two-column proof or formal proof contains statements and reasons organized in two columns. So when you're doing proofs, you'll have two columns. That's all it is. Two column proofs, okay? And what you're gonna, excuse me. So the example we had, when you're solving all the problems, you do on the left side, and the right side, you're gonna tell me what properties you're using. All right, so here's an example. Write an algebraic proof. If the formula to convert a Fahrenheit temperature to a Celsius temperature is C equals 5/9 times F minus 32, then the formula to convert a Celsius temperature to a Fahrenheit temperature is F equals 9/5C plus 32. Write a two-column proof to verify this conjecture. So begin by stating what is given and what you are proved. So a given is this. Okay, we need to prove that F equals this. All right. So here, when you do your two columns, you write your statements, and then you give your reasons. So anytime I say, let's do a two-column proof, you're gonna write the statement on the left side and your reason on the right side. Okay, so you're always gonna start with the given. So that's the easy part. You're gonna write down the given, just copy it down and write given, okay? So one correlates with one. Two, so you want to prove that when you move things around, F is going to equal this equation. Okay, so how would I solve for F? Okay, I'm going to do by multiplying the reciprocal 9/5 on each side. Okay, that is called a multiplication property of equality. So you're multiplying by the reciprocal. Once you've done that, okay, so 9/5 and 5/9, they cancel out, and you have F minus 32. So instead of writing all this, you simplified it. So whenever you simplify, you're going to write substitution property, okay? Because instead of this, I wrote that, so substitution. Now I'm going to add 32 to each side to get rid of this, okay? So I said add 32 to each side. That's called addition property of equality. And now you have F, and you have all this on the left. So instead, okay, so that we had substitution, and then instead, I'm gonna flip it over, and that's symmetric property. So if this is F, then F is that, okay? So we just rewrote it, okay? So that's how we prove, okay, so we got to, let me go back. So we got to from your given to your proof, and that's all the steps that you needed to prove it. Okay, so here's your turn 2A and 2B. All right, so this is going to take some time, so make a two-column proof. When you do two columns, okay, statement, and then the right side is, what was the right side? Reasons, sorry. Statement and reason. So you're solving this to find what x equals. each step of the way, you're going to write out what property that you're using. Okay, label it. For each step you take, tell me what property you're using. Okay. Same thing for 2b. It's just like the example we changed from C equals to F equals. Okay, so exactly the same with different equation. You're solving for U now. Okay, and same thing, 2-column proof, statement and reason. Okay, come back when you're done. Alright, so bear with me, it's just a little bit longer. We have 3 more slides to get through and we'll be done. Alright, geometric proof. Since geometry also uses variables, numbers, and operations, many of the properties of equality used in algebra are also true in geometry. For example, segment measures and angle measures are real numbers, so properties from algebra can be used to discuss their relationship as shown in the table below. So if A is B and B is A, no, I'm sorry, AB equals AB, reflective. And same thing if it's talking about angles, measurement angle 1 is equal to measurement angle 1. Okay, so anything that's related to segments will be the same as angles that we use in algebra. We're just going to use that same thing for segments and angles for geometry. Okay, so these properties can be used to write geometric proofs. Alright, so write a geometric proof. So again, we're doing 2-column proofs, so make a nice column, put statements on the left, reasons on the right. Don't block off the bottom yet because you don't know how many steps you need to take. Just start at the top. You always start with the given. Okay, so if angle FGJ is congruent to angle JGK and angle JGK is congruent to angle KGH, then x equals 6. Write a 2-column proof to verify this conjecture. Okay, so they're saying FGJ, this angle here, angle JGK is congruent to this, and JGK is congruent to KGH. So if this and this is congruent, they're all congruent then. Alright, that means this will equal that. Alright, so first thing you do is you write everything out and say that's given. Okay, now definition of congruent angles. Alright, so if the angles are equal, their measurement of the angles are equal as well. Okay. Transitive property of equality. Okay, if this is that and that is this, and this is this. So if, same thing as when we said A is B and B is C, then A is C. Remember that? Kind of like the law of syllogism. Same thing here. We're canceling out what the same thing is, so this equals that. Transitive property. Alright, so if measurement angle FGJ is equal to measurement angle KGH, then we're going to say 6x plus 7 equals 8x minus 5 by using substitution. So instead of using the letters saying that these measures are equal, I'm going to substitute it with what the actual measures are. Now we get to do the easy part, solving for x. Add 5 to each side, addition property. After you simplify it, substitution property. Then you're going to subtract 6x, subtraction property, simplify, substitution property, divide by 2, division property, have your answer, substitution, and then you're going to switch, and that's symmetric property. Okay. We're really stating what's obvious here, but it's just taking the long route, and we're just spelling out each single step for you here. So do this as if you were to write a textbook for someone who does not know this at all. Okay, so think of this as writing out the textbook. Okay, so they tell you each little step. All right. So here is your turn, 3A and 3B. So you need to do 2-column proofs for both of them. And then you need to verify each step. So go ahead and do numbers 3A and 3B, and when you're done, you are done with homework. I know this was a hard lesson. It will get easier as we practice more in class. Okay, thanks for watching.